We are going live.
All right.
Fantastic. Look at us.
Fun times.
The funnest.
So there's a little
Okay,
progress bar that's inching across my screen currently, but we might be live even right now. We're going to find out when we look at the recording.
I think in 20 seconds or so, it will appear on YouTube.
Yep, no, we're there now.
Great. Hey, everyone. Coiled and Prefect here. Hugo Van Anderson, Matt Rockland, Chris White, bringing live streaming of Dask, Prefect, and Coiled to you today. Modern data orchestration workflows and clusters. So while perhaps Matt and Chris introduce themselves, I'm going to share this link to this live on social media to get as many people here as we can. Great. So Matt, maybe you can take it away. Yeah, great.
Yeah.
Hey, Chris. Hey, Hugo. Hugo, I noticed
Hey,
that you've turned into some sort of broken mosaic of a Hugo. Are you okay?
Yeah, so this is, I think, another function of 2020. I've become a literal piece of paper. What has happened is I've had some back problems, some back spasms this week, and I'm horizontal currently. And I'm even more excited to be taking part in something like this when I can't walk as well as otherwise. But to that end, I've decided to not share my video. I'm sharing a mosaic of myself. And of course, there is the joke that when I ran a podcast that everyone told me I had a face for podcasting. So I think sharing my video is reasonable.
Amazingly, it looks like Zoom and YouTube Live done the right thing, and they're only showing Chris and myself in the YouTube stream. So
wow.
Oh, interesting.
Yeah, you're just the phantom voice behind it all.
I think it may have done that even if I was sharing my video. I think YouTube probably is smart enough to, although YouTube
Some
isn't
content
smart
filtering.
Yeah, exactly. Filter out the antipodes. Okay.
Quick introduction to Chris. So I actually met Chris years ago as a Dask developer. Chris implemented the first generalized linear models for Dask, doing a bunch of machine learning statistics kind of work. Chris then moved to Prefect, which at the time was a company of one person, two people?
I made it too.
The second person of Prefect. And now Chris runs the technology side of Prefect. He's the CTO. We're going to learn a little about Prefect in a moment. Hugo, are you ready to do slidey things, or are you?
In 20 seconds.
20 seconds. I got to keep like vamping for 20
Gotta
seconds.
keep it going.
Absolutely. I probably could do it in 15, but I'm kind of enjoying this.
Anyway, Chris has been a pleasure to work with, and it's been really fun. On the Dask side, we got a bunch of requests like, hey, can you do retries? Can you do, do this run this thing every hour? A bunch of requests that we got, usually from like Airflow or Celery users, that we said, yeah, we could do those things. They're not high priority. We'll get to them some point. Prefect came along, built on top of Dask, and solved all those problems. And so Prefect is a really nice tool because lots of times people come to us and say, hey, how do we do this stuff with Dask? And we say, go use Prefect. And people tend to be pretty happy. So Prefect is one of those technologies built on top of Dask. We're very happy to see them succeed. And I've actually never used Prefect in anger, Chris. So I'm actually looking forward to seeing you do things and asking a bunch of annoying questions along the way. Hopefully don't.
Please do. Yeah, one of the things that I hope to kind of get across here are the differences between Prefect and Dask, because I've definitely seen people who come to Prefect from Dask and think that it's a drop-in replacement, and that's not entirely true. We leverage Dask, but you kind of have to think about your tasks in a slightly different way.
Mm-hmm. Yeah, great.
So I'm ready to say a few words about who uses Dask. I like that Matt wants to ask some annoying questions because I'd like to do the same. And I reckon I can ask the most annoying question today. Not that it's a competition. But I'd like to say a few things about who uses Dask. But Matt, as one of the core contributors and maintainers of Dask and creators of Dask, could you just say a few words about what Dask actually is?
Sure. I guess you're going to force me to say this at every streaming event. But yeah, so Dask is a Python library for parallel computing that allows you to scale out different Python libraries to larger data sets, either on your laptop for out-of-core workloads or across a cluster of machines. Dask comes out of the PyData ecosystem, so libraries like NumPy, Pandas, scikit-learn, Jupyter, scikit-image, PyTorch, whatever. Dask is often a very native and natural way to scale those libraries. again, one of those libraries that's built on top of Dask is Prefect. So Dask really tries to be sort of a fundamental layer to provide just enough parallelism, but that's lightweight and simple enough so people are comfortable building other libraries on top of it.
And of course, there's a huge demand for a lot of organizations and teams working with Dask currently, which is one of the many reasons why we've formed Coiled. And what we're doing is building products to help data scientists, teams, and organizations scale their data science and machine learning work to larger data sets and larger models as well. So to that end, I just wanted to share my screen and just mention a couple of use cases. And you can check out last week's live stream where I went into slightly more detail here on these. But would you confirm that you can see my screen?
Confirmed.
Great. And it says who uses Dask. So I just want to go through a small handful of use cases. Essentially, Dask is used wherever Python is used, which, as we all know, is everywhere. In life sciences, retail, finance, geophysical, beamline facilities. In the life sciences, we see it used for high resolution cellular imaging. And actually, we're going to have a live stream with the wonderful people who work on Napari in several weeks. This is an image that Tally Lambert generated at Harvard Medical School. We've also seen Dask used at Novartis, and Eric Ma, who works at Novartis, will be joining us next week to talk about the type of work he does. And what he's explicitly said is that Dask helps them scale up their machine learning prototypes to production level machine learning. And that's what we'll be chatting about next week. Couple of really exciting cases in retail. I find very exciting Walmart. And this is actually as a result of work that Matt, among many other people, did in getting Dask working really well with GPUs and Rapids in NVIDIA. And this is a lot of machine learning. And correct me if I'm wrong, Matt, but this was Dask and Rapids and XGBoost, right?
And other things. It turns out that solving any problem involves lots of libraries. But
Yeah.
I actually never worked on this particular thing in particular. I just sort of tried to make it fast in the back end.
Yeah.
I mean, there's a great YouTube talk if people want to look at that thing afterwards. It's they have hard problems, Walmart.
Yeah, fantastic. And the other one, which is really exciting, and I hope to be bringing the people from Grubhub here soon, is word embeddings, because we haven't really explored yet all the wonderful uses of Dask in natural language processing and the world of word embeddings, which is really exciting. So as I said, I mentioned these examples last week, and if you go and check out last week's live stream, I mentioned a lot more. I just saw Pad Thai and Pad CU there, which I'm currently in Sydney, Australia. And one of the things I missed most living in the US about Sydney was the plethora of Thai food here. So I know what I'll be doing for lunch today. So I'm going to stop sharing my screen and hand over to Chris. We've said a bit about Dask and Coiled. I know a bunch about Prefect, but I'd love to hear Chris, the CTO of Prefect, to tell us a bit. G'day, Chris.
Yeah, hey everybody. Hey Matt and Hugo, thanks a lot for having me. Definitely excited to be here and run some Prefect flows against some Coiled clusters. So Prefect. So what is Prefect? The kind of canned response is it's a workflow orchestration tool. So what does that mean exactly? So for all of the Dask users out there, one way of thinking about Prefect is it's a level of granularity above Dask, and it layers on things like state semantics that allow you to govern your application and make stronger guarantees. So things like recovery from failure are a very important thing in the world of Prefect. One way that we actually think about our product is we think about it as an insurance product. So we kind of want you to not care too much that Prefect is around whenever things are going well, but when things go poorly, Prefect needs to shine. We want to help you kind of figure out what happened, get it fixed as quickly as possible, and move on with your day essentially. So things that we're going to see are so scheduling. Scheduling is an important thing, just regularly recurring work, which includes event-driven style scheduling. Retries, so just automatic retries. If you're hitting a brittle API and you want it to retry every 5 seconds up to 5 times. Things like caching the results of tasks for efficient recomputation. Other things would be things, so we're going to look kind of at our UI and looking at the different tasks in the UI and being able to very quickly just see like red and green. So Prefect layers on these state semantics where you can respond to failure in a first-class way. So whether that is a retry, like I already mentioned, or you could actually have task triggers where certain pieces of your workflow only run if a certain task fails in a particular way. And then also conditional logic can be baked in a first-class way. So something like, if my upstream dependency skipped, then also skip me. Or if my upstream dependency returned a list of a particular shape, then I want to run. Or you can imagine all the infinite variations on that theme.
Thanks for that great intro, Chris. And there was one other thing. You all have an amazing blog post about positioning good versus negative, positive versus negative data engineering. And maybe you could say a few words about that.
Yes, yeah. So this is one of the ways that we kind of view the data landscape, right? There's this meme that you spend most of your time data cleaning when you're a data scientist and only a little bit of time really thinking about your model. Same goes for data engineering. A lot of your time is spent recovering from these failure modes, trying to figure out what went wrong in my database, things like that. So we view the world, so positive engineering is the task, the collection of tasks that you want to get done. That's the reason that you write code. Negative engineering, on the other hand, is all of the code you inevitably have to write just to make sure that your positive engineering goals are achieved. And so Prefect wants to live in the negative engineering space. We want to help you write clean code that handles all of those sorts of things. Try except blocks, having a centralized place for logs, retries again. That's obviously a big part of Prefect. And so if we can, so let's just imagine that data folks spend 90% of their time on negative engineering. If Prefect can get that down by 10% even, we've effectively doubled your productivity. And that's kind of one of our missions.
I love that you mentioned that so much time is spent doing, all of these types of negative things. And I actually, there's that old trope, 80% of, data scientists' time is spent cleaning and preparing data. I actually wrote that in an HBR article 3 years ago. And then someone quoted me doing it. And now people ask me on Twitter, they're like, hey, Hugo, can you tell me where you got this quote from? And I'm like, I have no idea. I mean, this goes back to, people have been saying it for 10 years now. The other thing which we'll see, which I love, is that there are lots of great tools like your visualizations of Prefect flow via directed acyclic graphs. And that's something that, I think is incredibly helpful and intuitive for all types of data professionals to see. So I'd love to
actually, the visualization, that's kind of one of my goals here, is to show you side by side the Dask dashboard versus a Prefect dashboard. And I think just looking at those, you immediately see what is Dask doing for you and what is Prefect doing for you, and they're different things.
I support that. Let's move on towards that. I think we can talk about like what Prefect is, what it can do. I think it'll be much more fun once we have those things in front of us. So, hey, Chris, do you happen to have a workflow handy nearby that you can share?
I just so happen to. Let's see if I can share my screen. Here we go. I'm going to start out just with this notebook. Let me know if you can see it. I might need to make it a little bit bigger. Let me know if it's too small.
I'm sorry, I disappeared for a second. My internet.
We're good.
So I'm back and in action. Great. And I just wanted to say, everyone who's joining, thank you all for joining. And if you want to introduce yourself in the chat and say where you're watching from, that would be super cool as well. And if you've used Dask, if you've used Prefect, where you work, these types of things, it'd be great to know who you are and what you're interested in. So let's do it, Chris.
All right. So is my screen resolution good and everything? You can see what's going on here?
Yep.
All right.
A little fuzzy through the YouTube stream, it looks like, but I think it is still legible.
Okay, great. So yeah, the text here is not particularly important. And we'll share this as a gist a little later so that everyone can see. So what we want to do today is the PPP dataset that the SBA recently released for all of the loans in the US that were given to small businesses of, loans of varying sizes. So they made that dataset public. And so the goal today is to just kind of play around with that dataset. And one of the things that, I saw on Twitter recently that I thought was really funny is apparently Philadelphia in particular has just a ton of variations of how people spelled it in their loan applications. And so I figured we kind of take that, run with it, poke around at that, build a reproducible workflow, one that we can maybe parameterize by city, play around with some other cities, etc. So that's kind of the plan here.
Could you actually just show us the tweet? Because it's actually an exceptional image in the tweet, I think.
Yes. Can you see my screen?
Yep.
Yes. And
okay, so there you go.
That's wild, isn't it?
Every possible spelling you can imagine, including just casual Philly, which I find hilarious.
Yeah. I just want to say we've got people coming in from Switzerland, from Montreal, from Toronto, all types of places. Looks like they're spelling those names correctly. If you're tuning in from Montreal and want to show us all the misspellings, please do, but maybe don't drown out the chat. All right, enough from me, Chris.
No worries. Okay, so just to get things started, just to kind of get a lay of the land and everything, I just want to do some basic pandas. No Dask, no Prefect. Let's just take a look at this data set and see what we're looking at. So I've already downloaded it manually to my machine, so we're not going to worry about that. And we'll provide the link. SBA's got it on box.com. So this is the data set for all states for all loans that were greater than $150,000. And so let's just read it in and just kind of take a look at what this is. So a lot of categorical stuff in here. It's very granular, or sorry, it's not very granular data. So there's not too much you can do with a lot of this. So we see, loan range, business name, address, city, state, the industry code, maybe some stuff about the owner, and then which bank did the lending for this particular loan. So pretty straightforward, I would argue. Nothing too crazy here. So we can do some basic sanity checks, right? This is what everyone's going to do when they get the data set for the first time. So look at the different states. So 57 might seem a little high. So there are some US territories floating around in here, and then a few different versions of, basically not reported codes. So that explains that. And they have somewhat minimal data definition PDF that you can take a look at to get a better sense for that. So just to confirm that this is in fact a complete data set, I think most people know that Kanye West's shoe business took out a loan. So Yeezy LLC. So let's just see if that's in our data set.
Just for broader context, in case people are coming from other countries, the PPP, the Paycheck Protection Program, was a multi-trillion-dollar loan program that the U.S. government did to stimulate the economy during COVID. I'm actually amazed that this data is public this quickly. Like within months, they had trillions of dollars going out, and the data is available. That's cool.
Yeah, it's really interesting, and there's a lot of really interesting analysis out there, and that you can go check out from this data set. What we're going to do today is going to be just a little bit more on the fun side, but.
And also, I think we've made this clear, but I just wanted to point out once again that so much of data work involves making sure strings match and just really nasty stuff like that. I mean, I joke that we're still in kind of the dark ages in the sense that we still use regular expressions for a lot of things. So,
well, Hugo, don't judge me, but we're not going to use a single regular expression in this notebook. We're going to just use a basic starts with.
You've made my day already, Chris.
So no mental overhead of that. So let's just see if we can kind of recreate this ridiculous list of Philadelphia spelling. So I just create this mask. I have to do this equals true thing because some of these end up being nans. There's probably a cleaner way of doing this, so forgive my pandas. So we're just looking for anything in Philadelphia that starts with Phil. And then just doing some counts. So not that many, actually. We definitely did not reproduce the crazy large list that we saw on Twitter. And the reason for that is we're looking at the larger loans, and this is a nationwide data set. So there's fewer data points in this particular data set. So if you actually go to the SBA's website, you'll find there's state-by-state data for the smaller loans. And that's actually where a lot of the more fun, granular data is. So I also have already kind of gone out, downloaded that to my machine. So we've got it here specifically for Pennsylvania. And we can go do this for some other states in a little bit. One of the plans here is to set up a nice reproducible workflow for all of this. So we can read that in, just run the exact same code that we just ran and see. And now we get a nice long list of Philadelphia, et cetera, spellings. So one of the things when I first saw this that I, wanted to just play around with, and Hugo, you mentioned NLP earlier, so this is not true NLP, but we're going to use one tiny one tiny tool from the NLP tool shelf is the Levenstein distance between words. So this is also more popularly known as the edit distance between words. There's also something called the Hamming distance, but that's a pure substitution metric. So the words have to be of the same length. And as we can see, we got links all over the place here. So what I thought would be just a fun little exercise to do is to go through all of these misspellings and compute the Levenstein distance to the true spelling, and maybe produce a histogram or just get some counts of how far off most of these misspellings are.
That's awesome. And I think you mentioned it's the edit distance. So a kind of a basic heuristic to think about what we're measuring is how many characters you need to change and or add to turn one word into another. So kitten and mitten would be one. Have a distance of 1, for example.
That's exactly right. And you'll get a distance of 0 if and only if the words agree.
Yeah, awesome. Which accords or syncs with our intuitive sense of what a distance is.
Exactly. And so, okay, that's what our main
I'm sorry,
goal is.
Nicholas Brown just wrote in the chat, Philadelphia app should be the new capital. Now, I don't know what that means, but I find that hilarious.
Shout out to Nicholas.
Yeah.
So one of the things that I want to do here, though, is I want to build a pipeline. We're going to run it in a few different ways, definitely including on Dask. I want to build a pipeline that does this, this analysis in a way that we can parameterize and do for other cities and other states. So that's kind of the goal here. And I want to handle all the different failure modes. For example, I want this to all be programmatic. So I'm going to hit the Box API. If the API, for whatever reason, returns, a 500 response code, and I just need to wait a second and hit it again. I want to handle all of those sorts of modes. Another thing that I might want to do, because I'm hitting this external API that's, not in my control, I want to be a friendly citizen of the internet, and I don't want to hit it more often than I really need to. And so once I've hit it one time and I've downloaded the data, I'd really rather not hit it again to re-download that data. And so we're going to use some file-based caching here. And we're going to see how all of this plays with Dask and how Prefect, helps us put all this together. So let's just go down and look at, so I've already kind of written some of these functions just to avoid the cruft of writing a lot of code that hits APIs. So I have a few just basic Python functions here that I want to walk through. The details of some of these aren't particularly important, so we'll gloss over a little bit. If there are any questions, they're definitely happy to address them. So for the sake of programmatically downloading these files, I wrote this little function, download and extract CSV. So the files are stored, like I said, on Box. They're stored in a zip format. So there's all this little data processing that I have to care about to turn them into a CSV that pandas can interpret. So I have my Box credentials that I'm gonna have to feed as a dictionary. And then I have, so Box deals in these shared links. And so all of these files are represented by a Box shared link. So this is just some string URL. And, you can kind of look at this, squint a little bit. You see that I create a little Box client. Right here, I download the zip file. And then I use some Python built-ins to just extract that zip file to a temporary directory where I can then load it into pandas.
And I just want to say thank you so much for giving great doc strings as well, which seem rarer and rarer these days. And for those who haven't heard of doc strings, you can just below the function definition up the top, Chris has written what the function does so that anyone who reads the code now or later can actually see that. So I appreciate it.
One thing that I did not do is annotate this in any way to tell you what I expect this function to take. So that could have been, we've been using MyPy typing in the Prefect code base for a while, and it has its benefits. I really like it for documentation's sake, though, because now you kind of look at this, you're like, okay, I have a little bit better sense of what's going on here.
Yep.
And this thing is going to return the pandas data frame that we've been looking at before. So this is just a nice little function, so I don't have to go clicking around all the time. Okay. So a few other functions that we're going to want to use here in this pipeline that we're going to build. And one thing I want to call out is there's no Dask code here and there's no Prefect code here. This is just some Python code using some third-party libraries. So I'm going to extract city spelling. So this is just going to take, so this might require a little bit more explanation. So I have this config object, also a dictionary, and this is just what I'm going to use to parameterize this flow. So this config object, and we'll see this more concretely soon, I want to give it a city and the true spelling of that city. So in this case, Philadelphia. I want to give it the prefix that I want to search for. So this is my poor man's regex. We're just going to look at a prefix for all of these strings. And I think those are the only two things that are important to call out, at least for right here. So you can see that I take this prefix and I just lowercase it, and then I run that same little pandas line that I had before for Philadelphia, where I just look at all the cities that start with that prefix. And then I collect all the unique names and I turn it into a list. Now this is actually a little bit important, kind of forward thinking to Prefect. One of the features of Prefect that we want to use here is something that we call Prefect mapping. And so this is the ability. So remember, Prefect tasks are these, think of them as somewhat large creatures. And there's a certain sense in which that is very true, as we'll see when we look at the Dask dashboard. But so they, they have a state associated with them that if you run against our platform is actually stored in the database, et cetera. And Prefect mapping allows you to spawn at runtime dynamically many tasks based on an upstream iterable. And so in this case, this is going to be our upstream iterable. So it's the list of all of the possible spellings of Philadelphia that we saw. And what we're going to do is we're going to take this next function, compute distance, which computes this Levenstein distance that we talked about earlier. And we're going to map this function over the different spellings. And we're going to compute the differences to the real spelling. Okay, and then at the very end, of course, we're going to do, this is my histogram. We're just going to use collections.counter and just compute how many of the different distances we saw. No idea what to expect here. This could be complete noise. It could be particularly interesting. We're going to find out shortly. Okay, so none of this was Prefect. So now what we want to do is we want to build a Prefect workflow. And it's very similar to Dask. It's going to be a deferred computational graph. Prefect has its own way of building this, and then at runtime, we'll farm it out to Dask.
And could you just tell us a bit what you mean when you say a deferred computational graph?
Yes, that is a great question. So I want to say, for example, that this function, the data input here needs to come from the output of this function, but I do not want to run it when I make that specification. I just want to store the order in which all of my functions should run and which data, what data they each need to exchange with each other. And once I have that object, I can then choose to run it in lots of different ways. So I can put it in a Docker image and run it somewhere. I could run it on my machine. I could farm it out to Dask, whatever the case. I could look at it, which is something we're going to want to do.
So to parse that term, the computational graph specifies the flow of the data through the processes that we want to put it through, and it's deferred because we don't run it yet. We just set it up, and then when we want to run it, we can. Is that a good way to think about it? Yeah,
that is accurate. And so it's kind of, I sometimes think of this in like the software paradigm, right? There's a difference between compiling your code and running your code, and they have different things that you have to care about. So all I want to do is compile my workflow into an object that I can then ship around and run in different ways.
Awesome.
And so I'm going to now prefectify this. And I think, I hope it's actually going to be very underwhelming. So remember, one of my goals here is you shouldn't really care too much about prefect when things are going well. So I've already done some imports up here, and this first line is the one that we're going to focus on at the moment. So I have this little lowercase t task. So that's a decorator, and that allows me to just specify prefect tasks from Python functions. And then I have this flow, and we'll see how to use that as the container for all of the dependencies. So all I'm going to do is literally just that. So this, of course, accepts a bunch of configuration keyword arguments. But we have a lot of sane defaults here. So this is all you really need to just kind of get going for your first pass. Same with this, nothing too crazy. Same with this, and same with this. Okay, all I've done, and we can run this code. Oh, I didn't run my imports, so that's gonna hurt me. So I can run this code. Nothing's happened, except I have defined some tasks. I have yet to put them together in any interesting way. I've just defined them. And so to put them together, I'm going to enter And I'm actually going to cheat here for the sake of time. And then let me just remove that so you don't have to look too hard at that. So this is the code that I'm going to run to compile this deferred computation graph. So I enter what we call a flow context. So this flow object can be used as a context manager. And then every task call that is made within this context manager, Prefect tracks and just says, okay, you want that function to run, and then you want to pass the data to this function, et cetera, et cetera. And there's some, prefecty things lurking in here that we can take a look at. So first thing I do is I specify this prefect secret box credential. So a secret is a special type of task that has sensitive data. So my box API credentials are sensitive. And we can talk about how to inject those later. I have this download and extract CSV task, which I call on my box credentials, and config, which I did not define yet. So let me just, once again, cheat. And I'm going to put this right here. Okay, so this config task is a prefect parameter with a capital P. So a parameter is another special type of task, which optionally has some defaults like we see here. So we see the prefix Philadelphia, prefix Phil, city Philadelphia, and this SBA shared link. And we have a name for this parameter, it's config. Each time we run this flow, these default settings will be used unless I pass a new value. And so kind of one of the benefits of parameterizing your flow is once we do this one time and we decide to do this for San Diego or some other city, I just have to pass a new value for this config and my flow will just respond accordingly. And so, and we can also, similar-ish to Dask, we have a couple of little niceties where you can key into this config, and that's also represented as a deferred operation. Then we extract these spellings. So this is going to be a list at runtime. And then here is where we do some more interesting prefect stuff. So here we do a dynamic fan out, which is this compute dist.map. So this .map tells Prefect, okay, at runtime, depending on how wide this is, generate that many different tasks and feed each element of the list from spellings into the compute distance task. And each one of those things that is created is a true fully hydrated prefect task. So it can have its own state, it has its own page in the UI, it can retry independently of all of its siblings, et cetera. So it's a true first-class object. And then we have this unmapped container, which is just an expression in Prefect to say, here's something, don't map over it. So pretty straightforward there. So we just want to pass in the true spelling for the city. And then last but not least, we have this reduce step. So this is kind of like a, somewhat like a map reduce situation where we're going to take the collection of distances that we computed here and then just aggregate them using that Python counter. So does that all make sense?
That makes perfect sense.
I'm excited now because I think we're at the point where we get to see a dashboard go or pictures. And I'm very excited about that.
Yes. So cool.
Wow.
Flow.visualize. So this is not a dashboard, not quite flashy quite yet, but we will get there.
Excellent graph
in due time. Yeah, exactly. All the Dask users, this will look very familiar. So, these are those get item, deferred get items that we had. And then this dotted line in a prefect graph means a mapped edge. So this is going to return a list and then going to compute, lots of different tasks here.
So could you talk us through just this visual from top to bottom in terms of flow? And also, let's make clear, this is a what people call a DAG these days, a directed acyclic graph. So the graph, I think, is self-explanatory. It's directed in that from each circle or box to the next, you've got arrows, so there's a direction. Acyclic, all that means is that there are no cycles. You can't go around in loops there. So it's kind of a slightly obtuse term for something which I think is quite intuitive.
Yep, that's exactly right. Thank you, Hugo. And so the way that this works in Prefect land, and one thing too for the Dask users out there, hopefully when you look at this, you see that the level of granularity that Prefect cares about just from the flow that I built for you here is quite different from Dask, right? We don't care about a lot of the nitty-gritty computational details inside of the task. We care more about the surface area around them. So each of these usually represents some unit of business logic. Obviously, we have a few smaller tasks in here like get item. That's okay, but the bigger ones are business logic. So this config parameter is something that by default will use the values I provided it. And then it's going to get passed to this download task, which is going to hit box and pull that zip file and unpack it. And then, which also requires this prefect secret box credentials. And then all of that data is going to get passed to this extract city spellings task, which also depends on the configuration values that I provide. And that's going to give us all of the various spellings of the cities, which will then get mapped over. So each spelling individually will get a distance computed. And then finally, we're going to aggregate those distances into a Python counter.
This is awesome, dude, because this is exactly what you would do using your own pandas foo each and every time and have to do time and time again. And so this is a beautiful example of how it makes the whole process more efficient and reproducible and shareable as well. So thank you.
Absolutely. And so running prefect flows is as simple as calling flow.run. So this is all kind of our interactive flow building experience. And so this is going to take, it's going to be pretty quick. All of these calls are relatively quick. You can see prefect likes logs. So there's a ton of logs here, which you can kind of dig into. We're not going to walk through all of them, of course. But the one thing that I do want to call out about these logs is you can see all of these state changes that are happening. So states are really the currency of our system. We have something like 30 different states representing all of the different states that your task can be in. So you can see handling state change from scheduled to running, pending to running, running to success, et cetera, et cetera. And if we kind of go down to the bottom, we see we spawned about 40 or exactly 49 tasks. That could be different every time we run this flow. And we did get a success at the end. And so what we can do now is we can take the state of this flow, and then use this. So the result of a flow are all of the individual task states. And we can key in, let me see, what did I call it? Results. So we can key into this dictionary to get the final terminal task state, which, sorry for the overuse of the word result here, we can get a little counter. And so the only thing about this counter, so there's two things that surprised me quite a bit, actually. One is the distances are quite far. None of them look close to the spelling, so that seems suspicious to me. And the second is the fact that 0 doesn't show up here is also a little suspicious to me, because the true spelling of Philadelphia should have been in here somewhere. I do not know the answer to those two questions, but that's just the thing that strikes me when I look at this.
Yeah, and that's something we'd want to debug on a next step. But essentially what we're doing here is a form of exploratory data analysis, right? So I think that's that's totally fine.
Exactly. And so, okay, the thing that I want to do next now.
Maybe I'll just make explicit that what the counter actually, correct me if I'm wrong, but the counter is actually a proxy for a histogram, right? Where so it looks like a dictionary where we have the keys are the distances and the values are the number of occurrences of those distances. And as I emailed Chris, I got to give a shout out to counter and the collections module, which is my favorite module in the Python standard library.
It's so handy.
Awesome. Yeah. Default dictionaries. Okay. Sorry.
Oh yeah, I love default things. Yeah. So the next thing that I want to do is I want to layer on some more features onto this before we start running this against a Dask cluster. So the first thing that I want to do is we're hitting this API with this download and extract task. And so I just want to show you what it looks like to configure retries. You know, we can make up some joke tasks that fail randomly or something. I think you get the, you understand the idea here. It will just automatically rerun at the specified time. So we can say max retries. Let's say that we only want to retry twice and we need to specify a retry delay. So I've already done some imports up here, but I think I have date time. So let's just say that we want to wait 2 seconds before we try again. So you can set this to 0 if you want immediate retries, or you can set it to longer. You can set it to a full day or whatever the case may be. Okay, so that's the first thing. So now that's just a little nicety. It's going to retry if it encounters any sort of unexpected error. The other thing that I want to do that I mentioned, and I know this is one of our more popular features that we released somewhat recently, is I want to cache the output of this task. And so what I want to do is I want to store this somewhere. And because I know I'm going to be running this on a Dask cluster soon, I want to store it in the cloud. I don't want to store it on my local machine. And if I've already stored data in whatever location we're about to configure, I don't want to rerun this task. I just want to use that data. And this kind of, so you can kind of think of this as like a snake make for any, or Luigi, I think, has something like this as well. So just file-based caching. Now, one of the cool things though about the way Prefect handles this, because you know, the ability to pass data, you can do some really interesting templating things with your files. So once again, I'm going to cheat just a little bit and take this because I don't want to forget my bucket name. So we're going to create what we call a result on this task, result with a capital R. So I imported this, you can see above, from Prefect's results library. So we have S3, GCP, Azure, you know, you can imagine all the variations there. So Prefect Coiled data, that's a bucket that I own. I have it over here. There's nothing in it. Sorry for the jumping around. So the first thing that I can do is just say result equals bucket result. Okay. So what this is going to do, as currently configured, is this is going to checkpoint my data. So every time I run it, it's going to just write to this bucket using like a timestamp basically for the file name. That's not exactly what I want. I actually want it to cache and reuse the data instead of recomputing it. So the next thing I'm going to do is specify a target. And so this target is going to be the file name that I want for, you know, how I store this data in my bucket. Now this file name, I could hard code this. I could say like hardcode.bytes because it's going to get stored as bytes by default. But that's a little boring because if I start running this for other cities, I don't want them to get confused and like accidentally use the Pennsylvania data when I'm trying to run Arizona or something like that. So what I'm going to do instead is I'm just going to call it formatter. And I'm going to make a function that's going to take in a bunch of inputs that Prefect provides. And I'm going to use those inputs to template what this file should look like. So in this case, I'm going to actually use this shared link because that's going to be unique for each file that we process. And if I remember correctly, what I want to do is base name shared link plus .bytes. So I think this is going to take the last little piece of this URL, which will be a unique ID.
Do you want kwargs of shared link by any chance?
Oh, you know it. Thank you very much, Matt.
This is how we know we're doing it live.
Yeah, exactly. And so instead of this hard-coded string, I'm going to pass this callable, which at runtime will get called, as you might expect. So I wanted to do this because now I want to just rerun this and just kind of show you, since it's a fast flow, show you what we get on the other end. So visualize is the same. We didn't actually change the structure of the flow. We just changed some of the configuration of it. So we go down through here. And here you go. Task download and extract CSV. It ran because my bucket was empty. And now it's uploading that data frame to this templated location, which this is the box file name ID. And then things keep going, etc. We can go over here to my S3 bucket and do a nice refresh. And there you go. It's not interesting to look at because it's a collection of bytes, but.
That's
you made
awesome.
A thing appear on the cloud.
What's that?
Still, you made a thing appear on the cloud. Isn't that
exactly?
Nice?
From a Jupyter notebook as well.
Right. Exactly.
Which is very
and so
cool.
I'm just going to do a quick rerun just to convince you of both prefect states and the fact that this is doing something interesting. So go right here, logs, we see starting task run. And the first thing that we see now is starting to download result. So we're not uploading. We didn't rerun this. Finish downloading, task, handle state change from pending to cached. And then we move on. And so now we know the cache was used because this is a cache state. Okay. So everything we've done, I've kind of highlighted a couple of little prefect features and we've run this locally in process. So now let's get to the more interesting stuff. So I'm going to ask everyone to entertain me a little bit and imagine this workflow is much beefier than it actually is. So imagine these tasks are, computing this distance requires like multiple CPUs or a lot of memory, something that just isn't going to work very well
Hold
on
up,
my
Chris.
local machine. Yeah.
That sounds like something that Dask could be useful for.
Ooh, that's a good idea, Hugo. Let's.
And maybe even Coiled at some point. Oh, wow.
I don't know about Coiled, but we can definitely do Dask.
Okay.
So.
Hey, wait a second. No, I'm kidding.
I'll take it.
What I'm going to do is I'm going to import Prefect's Dask executor. So Prefect, as Matt said at the beginning, Prefect was built with Dask in mind as a first-class citizen. Dask is our go-to for any sort of parallel computation. So everything I just did was sequential. And if you want to run things in parallel, we tell people to use the Dask executor. So by default, as with most things in Dask, this is just going to create a local cluster. And we're going to get a little bit of multi-processing, multi-threading. So run this again, get a little Prefect deprecation warning so we can ignore that. And no surprise, this is going to run, this is also going to use the cache again. So we're not going to continually hit box every time we run this through the rest of the demo. And it might be hard. So, and we'll motivate this a second. It might be hard to tell from the logs, but this is running in parallel. You can kind of get a sense of it by looking at the different compute distance logs. They're all like intermingled. So we have lots of things running at the same time. And no surprise, we get, you know, what looks like the same result that we got before. Okay, great.
And one thing to note is that, and I think you mentioned this in passing, is that we've already identified we're computing a bunch of different distances. So this is a prime case for something to do in parallel, or something that we can parallelize, right?
Exactly. Pretty much anytime someone uses prefect mapping, that generates a naively parallel pipeline. And so 9 times out of 10, when you see the use of .map in prefect land, that's someone who's running on Dask.
Awesome.
Okay, so that's pretty cool. But what if we want to run a different type of Dask cluster, Kubernetes cluster, Fargate cluster, or better yet, Coiled cluster? So the Dask executor here, Prefect, knows how to manage the life cycle of a Dask cluster. And a lot of props. So Jim Christ, who is also a prominent Dask developer, is on the Prefect team. And he's been spending a lot of time recently in just improving how Prefect talks to Dask. So I take full responsibility for everything wrong with how Prefect talks to Dask, and all the good bits is what Jim's working on and making sure work really well.
Fortunately, Jim is also in the chat. If people want to ask any Dask question, they want, I'll happy to volunteer Jim's time. Yeah. We are low-ish on time, by the way, Chris. So if you are able to accelerate things or jump to more exciting bits, I recommend you do so.
Okay, let's do it. So what I want to do, I want to do a quick run against Coiled. Shouldn't take too long. And then I want to do a run using both Prefect Cloud and Coiled simultaneously. And I want to talk a little bit about why that's interesting.
Cool.
So Coiled Dask run. So for those of you, most of you I think know, Coiled provides managed Dask clusters that you can spin up on demand. I am luckily in the closed beta, and I do have a Coiled account, so I have been playing around with this, hooking it up to Prefect and watching things hum. And so Coiled has a Coiled cluster object, meets the standard interface for all Dask cluster objects, and Prefect's Dask executor knows how to reason about Dask clusters. So we pass it this cluster class, and we pass it some configuration. So in Coiled, you have 2 things that you have to create. You don't have to create them, but if you use custom packages or anything, you're going to want to create a software environment and a cluster configuration. And so I've already done that kind of behind the scenes. I have an addendum here that shows what code I ran to do that. So I've got a nice public Docker image with all of my dependencies baked in. And so what I'm going to do is I want to hit this. So we see Prefect is taking care of our cluster creation. I don't really have to know too much about that. I don't have to worry about managing that myself. And in just a second, whenever this starts running, I want to click through to our dashboard really quickly. And
so
then
running this locally, like when you made the Dask executor, which is a Prefect thing, that created a local cluster, a local Dask cluster locally, ran your Prefect flow on it, and then tore down that Dask cluster. Is that right?
Yes, that's exactly right. And so huge difference here, because now all of my computation, other than just the basic flow process, is being farmed out to a Dask cluster that's living in Coiled's infrastructure.
Right. So the minute delay we're seeing here is my fault, not your fault. We're taking like a minute to spin up resources on the cloud or whatever. So here's where we're like, we're waiting for AWS to give us some nodes.
Exactly. And so
I'll also add that this has abstracted away a lot of the stuff that data professionals need to do on AWS. So you get to do everything that you want and more on the cloud from your native environment of a Jupyter notebook. Chris also mentioned that he's able to do this because he's involved in the closed beta that we have at Coiled, which all of you can sign up for as well on our landing page that I've just included in the chat as well.
Subtly done, Hugo. Subtly done.
Yeah, a master of subtlety. Antipodean subtlety, as we call it.
And I will take at least a little bit of responsibility for this. My Docker image, I think, is quite large, and so pulling it could also be adding a little bit of latency here. In the meantime, though, I want to prime what I want to do next. So Coiled is managing my compute for me at this moment. And that's kind of what we're waiting on, is for Coiled to provision me some infrastructure. Oh, look, it actually had ran. So I'm actually going to click through really quickly to this. Oh, no. Did I lose it? Did I miss it? I really wanted to show the task graph, but it looks like I might have been a little too late.
Yeah, the Dask dashboard, if you go to the tasks page, it might be there. If you, no.
No, I think I lost it. Okay, so apologies for missing out on that, but regardless, I could have done that.
On a different, one of the existing clusters, maybe?
I can definitely try. So let's see, I'm gonna maybe provide, oh, that has num worker 0. That doesn't look good. So I'm gonna do, let me use that one, and I'm gonna provide, I think, the name. And is there another option that I need to be providing here?
This might also fail. Coiled is pretty rough at the moment, so we'll try it out.
Let's find out. Nope. Unexpected error in the flow runner, was unable to create this cluster or talk to it. So no big deal. Okay, so the Dask cache stream, though, the main thing I want to highlight, and for the sake of time, I'm not going to rerun this just because it's going to take another minute or two. The main thing that I wanted to highlight with the Dask UI is it's a great place to go for looking for how to improve the efficiency of your compute. So if we had caught that task stream, what we would have seen are some pretty sizable gaps in between our tasks. And the reason for that is serialization overhead that Prefect takes responsibility for. So our tasks can be a little large. We're working on getting that down, but you can see that very prominently in the Dask UI. And so that's where you're going to go if you want to figure out how to optimize your compute, how to make sure your work's being spread across your workers and that sort of thing. So I want to contrast that with the Prefect UI. And so what I'm going to do with this flow is I'm going to register it. So I already have a Prefect Cloud account, no surprise there. I have a project in Prefect Cloud. It's a directory structure for organizing my work. And I want to register it to my Dask Flows project. So just did that. Prefect Cloud is now aware of the existence of my flow on my computer. So let's click over to this link. And what we're going to see is some details about this flow that I just registered. So the flow still lives on my machine. This is the thing that I really wanted to highlight about the complementary aspects of Prefect Cloud and Coiled, is that Prefect Cloud does not manage compute. Oh, sorry, what's that, Matt?
You just bump up the window size.
Oh yeah, thanks for.
Beautiful.
Okay, so we have for users and all this fun stuff. So you can see that it was created by me at a certain time. You can see what Prefect Core version I'm using. I am using a locally a little bit hacked version for some other stuff. You can see that it's running on my machine, et cetera, et cetera. But the schematic, this is a slightly prettier version of the one that I showed you before. We can kind of click and explore this. We can see that this has some retry settings. We can see the retry delay. All of what I would call business logic about our workflow. And last but not least, I want to run this to show you what the Prefect UI is good for in contrast to the Dask UI. Oh, and sorry, I was wanted to finish up one other thought, which is that Prefect Cloud operates purely on metadata. So my code is still living entirely on my machine. I did not just send Prefect any of my code. And also the data that I'm creating between my tasks is not being sent to Prefect Cloud. And so we have this hybrid model of execution. And so Coiled fits really nicely here, because if I don't want to worry about managing my own Dask cluster, I can use both Prefect Cloud to orchestrate, schedule, hit the API to do event-driven stuff. And then I can use Coiled to actually handle my large compute. And so the only other thing that I want to do, and this might error out, it did not. Okay, so I'm just starting a little local agent. Yay, Prefect agent. Go over here
And I love
sorry,
me
it's a
some
little
ASCII art, so to speak.
Oh yeah. Josh, you can thank Josh Meek for that one.
Thank you, Josh Meek. Deep gratitude.
And so now it's in a submitted state. Once again, states are everywhere in Prefect, and we can see it doing its thing.
Oh, look at that.
Yay.
That's really cool.
So the work is still happening on your MacBook Pro or something. But your MacBook Pro is just sending updates up to prefect.io in order to so that you can then see them.
That's exactly right. And we can click in and we can look at all the mapped runs being generated.
Probably there's like some history here too. Like you can go see what you did yesterday or something like that.
Yep, and all of our logs are coming in, so we could go look at the logs. We could look at a Gantt chart of how everything's running. The biggest thing that I wanted to highlight is just this looks drastically different from the Dask UI. And I think the differences in how they look and feel are emblematic of what they're best suited for. So obviously in my situation here, this would be a really great visualization if things were going poorly. I would just look for red and then click the red and look at the logs. Whereas if my work was taking a really long time, I would go to the Dask UI and I would poke around and see why are workers not getting allocated work and things like that.
Right. So if you're asked a question, let's say this is taking a long time, it's like, hey, what's slow? You could probably say like, oh, we're spending a lot of time in the box creds task, for example. But going deeper than that would be hard.
Exactly. Going in, once you hit the compute layer, Prefect doesn't have access to your infrastructure. So you're going to have to rely on Dask.
So we have a few minutes left. What are your thoughts on wrapping up, Chris?
I mean, I have one other thing that we could do. We definitely don't need to, which is just I could invite Matt to this and Matt can look at it too. I think another one of the things that I at least wanted to call out, I don't know if it's worth the time or not though, is just this is meant to be a collaborative dashboard. And so I can invite Matt to my tenant. He can come and look at the same screen I'm looking at, and he can start hitting quick run and providing new city names, new SBA links, etc.
Look, at the risk of going slightly over time, I for one would love to see that. If people need to check out at the hour, I'd just love to say, thanks for joining. Check out Prefect. Go and, check out Coiled's landing page. Follow us on social. Sign up for our closed beta. Chris, before we do that, maybe you could just tell us if people want to get started with Prefect, how they could do that or where they could go.
Oh yeah, that's a great question. So two ways of going here. So the first, definitely recommend checking out our open source package. You can do a lot with it. It also has an open source version of our UI. And basically anything that you want to do interactively, you can use our open source package for. And then if you want to see the screen that I'm looking at here and do some more collaborative work, I recommend you go to cloud.prefect.io and you can grab a free account and start running flows away.
I'm doing this right now, assuming you need me to do this in a minute.
You don't necessarily have to.
Well, I'm
but
doing it.
Why don't you give me, what email address would you like me to use, Matt?
This is like it's the normal one you would email me at. That's not that. It's mrockland@gmail.
Sorry about making that public, and I'm just gonna let you be a user.
We also need your password, Matt.
Oh yeah, sure, no problem.
Oh yeah, we will need to screen share as you log in.
And your 4-digit PIN for your date of birth and your mother's maiden name.
And your mother's maiden name as well.
Okay, we both got there. That's awesome.
I've been invited to Prefect Cloud. View invitation. So this is actually gonna be a little awkward because I'm on my giant monitor right now. But it sounds like I should screen share. Is that right, Chris?
Yeah, you should screen share. Kick it off.
Yeah, 1 second. Let me switch this off to some other window.
And I did not, in my haste, I did not configure this flow to run against Coiled, but we could have done that.
Just fine.
Awesome.
Especially given our poor performance recently. Yeah, okay. I think you're seeing a giant Prefect logo.
We are.
Yep.
Fantastic.
Welcome to the cloud.
Very fun.
Yeah, okay, wow. That was an easy one.
All right.
So wait, this is because Chris just invited you? You've now got access to all of this?
Yep.
Wow.
That's exactly right. If you go up into the top right, Matt, and click that little magnifying glass search, you should be able to search for Coiled. I believe I named the flow.
I'm curious though, what am I looking at here? What are all these flows?
So these are flows that we play with.
And you'll see there's one called bank transfer, which is all of your funds being drained currently, Matt, after giving us
There you go. Yeah.
This is fun.
And so if you click run, just the big run, not the quick run button, so we're not gonna have time to come up with the config probably, but just to show you what I meant when I was talking about this. So these are my defaults.
So I can do this.
Exactly. Now you can start playing with it. And so you are going to get a failure because that link is for Pennsylvania specifically. I can give you the California link if you'd like though.
Go for it. I'll do this Philadelphia one in the meantime.
Okay.
So I click the button, and presumably that is causing work to happen on your computer.
Yeah, that's exactly right.
Great. I like where this is going. Running flow. So on the right, I'm seeing the various, looks like maybe the various state transitions between all the different tasks. These are probably in queued, maybe, and these are finishing down here.
That's exactly right.
It's almost like I've played with task scheduling systems before.
And if you click that schematic, that's the view that's my personal favorite.
That's really cool.
And so, yeah, you can see these are all executing sequentially because I did not configure it for Dask, although I should have. And if I did that, I would just re-register a new version of the flow.
Mm-hmm. Right, so you could like swap out that coiled cluster for local cluster or kube cluster or whatever other Dask cluster thing.
Yep, exactly.
And then this would be running in parallel. Then I would see in this Gantt chart, I would see, so it's kind of hard to tell because things are updating, but like I'm seeing
it's updating a little quickly.
On lower bits here, there's a bunch of boxes that are all, none of them are vertically aligned. All of them are staggered. And so presumably if we had Dask running, you would have many things here running in time at the same time.
Yeah, it would be much faster than what we're seeing here.
Mm-hmm. Lovely, cool.
So yeah.
I like how quickly we were able to go from you running something on your laptop to me having a button that let me run something on your laptop.
Exactly, and everything you're seeing in this UI is exposed through an API, and so you can really, have a field day, kicking off flow runs from various locations, querying for history, etc. Oh, and I have that link for you. I can put it in the Zoom chat.
Los Angeles isn't quite. I was trying to find like the nearest major city to me. It's not quite the right one, but maybe like Albuquerque would be better. I actually need some help. I think this is correct. I could be totally wrong.
And thank you, Chris, for taking us in such an intuitive way from working locally in Pandas code to then moving to Prefect and then moving to Prefect on the cloud and then with Coiled as well. That was really cool.
Yeah, thanks for the opportunity. And I mean, one of the cool things here that at least I hope we are contributing to is the screen that Matt's currently playing on could be a business analyst playing with that, running flows against a Dask cluster that they know nothing about. And so giving access to that kind of powerful compute layer through a more, I'll use intuitive API from the business analyst perspective.
Yeah, so one way I think about that is abstracting away the technical details that help meet the end user where they are, right?
Yep, exactly.
Awesome. Well, on that note, I think that's a good point to wrap up. I'd just love to thank everyone who joined and stuck around. We've still got a lot of people here who were here from the start, so that was really cool. Always love chatting with Matt. Let's say 98% of the time. Always love chatting with you, Chris. And it's it's so great to be chatting more and more with you and Prefect and working together as well as we build Coiled. So it's great to have you as family and friends over there also.
Absolutely, right back at you.
Awesome, cool. Well, as we said, check out both Coiled and Prefect, and let us know your thoughts. Feel free to ping us at any point.
Awesome.
Thanks, everyone.
All right. Thank you.
Bye, everybody.